Welcome back to part 2 of our naming series, and this is going to be naming binary covalent compounds. Now, we're still talking about chemical reactions, and in this case, we're talking about sharing electrons, which helps create a covalent bond. Generally speaking, nonmetals will team up together and have shared electrons that will form a covalent bond, as demonstrated here by our classic water look. We call covalent bonds molecules as opposed to compounds. Nobody's ever going to tell you you got something wrong like that, but it's an interesting convention that we have. Now remember, nonmetals are in that funny little triangle corner, and there's not a lot of bonding that goes on with our noble gases, and just hydrogen can also behave as a nonmetal, so it will often be used for making molecules. Now, when you're naming, you have to determine if it's ionic or covalent, and ionic elements or ionic compounds always have one metal, where covalent compounds contain only nonmetals. So you can make it pretty easily by checking that out. Now, when we're naming our covalent compounds, it is a little bit more involved than our ionic ones. It's because you can make a bunch of different covalent compounds, even with the exact same types of atoms. So the easiest type of covalent compound to name is what we call a binary covalent compound. Binary, in this case, simply means two. So we're going to have two different nonmetals grouping in any variety of numbers. Now, because we can share our electrons in a lot of different ways, we could get things like carbon and oxygen teaming up as CO or CO2. Phosphorus and chlorine could be PCl3 or PCl5. And nitrogen and oxygen mixtures, I say this all the time in class, if you don't know the difference between the nitrous oxide that you put in a car and the kind your dentist gives you, you should always be careful. And when we have our name, we're actually going to, in the name, explain the correct ratio so that we can indicate what we're talking about. And to show the correct ratio of elements, we're going to use prefixes. This is the list from 1 to 10 of our prefixes. We have mono for 1, di for 2. So I know we said binary compound and now we're saying di is 2. There's a little confusion sometimes between Greek and Latin prefixes, and we tend to use them both in science. Tri is 3, like a tricycle. Tetra is 4, like tetrahedron. Penta and hepta come right out of geometry, a pentagon and a hexagon. Hepta is 7, which is a little odd sometimes to hear. Octa is 8. Nona is 9, and deca is 10. Now, our steps for naming covalent compounds: first, we write the name of the first nonmetal, and then we ide it on the second nonmetal. Then we have to add prefixes to specify how many of each element are present. In this case, it's dinitrogen tetroxide. When we're using our prefixes, they're only for binary covalent compounds, and the prefix mono is never used on the first element of a binary covalent compound. Generally speaking, the first element is just a one of, so we stopped using mono to save time. So CO2 is carbon dioxide, not monocarbon dioxide. And we remove the vowel from the prefix when adding it to oxide, so it's carbon monoxide, not carbon monoxide when we name that guy. It really is that easy, and I'm going to pepper in some checks for understanding and an extra question right now, but you do just look at the chemical formula, add prefixes to each of the chemical species we have in our covalent compound, and add "I'd" to the guy at the end. I hope that you've learned something with this, and I'll see you in class.